Everybody's Tyler here at Chesney Champs, checking out team number 5460 Strike Zone coming out of Michigan. And I'm here with Archer and Lily. We're going to be breaking down this awesome robot that we've seen. You might have saw an interview we did with them early in 2020. We'll be talking about some changes going on, of course, with this really cool robot. Going through that power cell journey, intake into Spindexer, shooter, climber, all this and more coming up here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We'd like to thank Stryker for their continued support of First Updates Now. Stryker's internship portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. We'd also like to thank Kettering University. Kettering University is where robotics students come for their education. Over 30% of those who attend Kettering University were in high school robotics, and you can keep going with their BattleBots, VexU, esports, and First Mentorship programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021.
So starting out on the spot here, Archer, take us through the intake. Talk to us about some of the iterations that's gone into it. You guys got a lot of compliant type wheels on this as well. Tell me a little bit more about it.
Okay. So first of all, we decided to kind of go with a just big intake to be able to take it all the way up to the Spindexer, and that is aided by a kicker bar. We firstly tried to do Mecanum wheels with Versatube rollers with like a rubber filament on it. We then decided to switch to vectored wheels and 2-inch compliant wheels, kind of modeled after 254's intakes because we took inspiration from them. One other key thing to note for the intakes is if somehow our belt system fails, we do have a kind of wall pusher that we can slam into a wall.
Nice, yeah.
And then just drop them in there. That takes it to the Spindexer.
Well, before we do that real quick, can you talk to us about this drop down here as well? And then I'd like to hear anything about programming potentially with that too.
Oh, sweet, yep. So this, we call it a kicker bar. It's basically just 2 static bars that drop down at the beginning of the match. That's just passively drops down using rubber bands and the outtake of the intakes. That is locked in by these little rubber banded fingers. And that just keeps it so that the balls are able to go against a stable object instead of the squishy bumpers. And that also prevents the balls from going under the robot and prevents the driver from driving over balls.
And how is that controlled from a programming standpoint? Is the driver just pressing a button? Is there automation that goes into it? Talk to me about that.
Yeah, so with the program, the good thing about using this model and this design is that it's not complicated for us to do. It's not very difficult for us to put on a button. It's just, we just use two bumpers and we have them on the controller. And it's just the driver has control of pushing this mechanism out and controlling these wheels. That way it's not difficult for them to communicate between each other, but we like this design because it's easier for us to program. It's not anything difficult. We don't have issues with our program using these because of how easy it is for us to use.
Well, Lily, let's stick with you and talk about the Spindexer a little bit from a programming standpoint. I saw when a couple power cells came in, it looked like they kind of got stuck a little bit, but then the Spindexer reactivated. Is there anything that goes into that from an automation standpoint or programming you want to talk about?
So we have a semi-autonomous sequence for that. Depending on how stuck it gets, we can unjam it. So it just, if it gets stuck, it just automatically spins the other way, depending on how long the balls are stuck together. If we have a really large buildup, we can manually unjam it in case that sequence fails. But it works almost all of the time, because that's the coolest thing about this Spindexer area is that it works. And every time it gets jammed, we can unjam it.
Makes sense. Talk to me a little bit from a mechanical standpoint going into a Spindexer. Has your team done a Spindexer before? And I'd love to hear about having that kind of the kicker mechanism in the middle of the Spindexer. Is that something I think is a little bit more unique for your team? A lot of teams will put it kind of in the back of the robot. Yep.
So originally in the 2020 season, we had a completely different robot. And that just had a linear travel for the indexer system. A couple of problems with that is if it got jammed, there's very few ways to unjam it during a match. And so the thing with a Spindexer is it is easy for it to jam if you don't have certain things in place to keep it from jamming. But it also gives you the ability to write semi-autonomous programs and also manually control it to unjam itself a lot easier. And then with this little pneumatic, if you want to put it out. So our center column indexer is intake using this pneumatic wheel attached to the piston. And that allows us to, regardless of where the power cells are in the spindexer, the turret can turn wherever it wants, over 360 degrees. It will still be able to pick it up the same. It could be over here or over here. And that just allows a very consistent path of travel for the power cells.
Can we see that spin up and kind of look at that process one more time?
So you'll see it kind of idle up now, getting up to speed.
One of the things too, we'll be talking about your turret in a little bit, but we can see how your Limelight is navigating that with the target, which is really cool too. So,
Yep.
so let's keep moving on then. Let's go into your turret and your shooter as well, and talk to me a little bit more what's gone into this design process.
So with our shooter, we just wanted it to be a lot better than it was because we had a couple issues with it jamming in the hopper area, and then we have these two. We have these ones up here. We have two flywheels almost, and this helps stabilize the shot.
Sure.
Which is a really big issue that we were having, and it also helps keep the velocity stable because during the entire match, we have an idle velocity that we like to keep at around like 30,000. And when we want to do that, we use our Limelight to help us use our distance. So depending on how far away we are, our hood will go up and it will adjust, and our velocity will also adjust. So having this here also helps keep the velocity stable and helps us ramp. And then we also have an inertia wheel to help just keep that more stable. That way it doesn't ever drop for any reason. That way if we do miss, it's not for that reason.
So the way you're using your Limelight, just paraphrase, is that you're using the adjuster hood and it's also adjusting your RPM on your motors as well too, right? So talk to me about some of the your iterations and process as you went through that, like from where you first started to where you are now. What changes have you made from a programming standpoint on that?
So at first we had to do manual different adjustments. We had to test for what position was best, and then eventually we got to the point where we didn't really have to do that as much. We got the data points that we needed, and we had to write our own mathematical equation that we had to use, which I don't know off the top of my head, but.
No,
so
we won't make you recite it all. Don't worry about it. So
we used all those values, and it helps us adjust, and it's a lot easier once you get used to it because we've had to do it 3 or 4 times because every time we modified something, we had to change the code, and it's good that it works.
Absolutely. Before we move on, but from the turret and shooter, by the way, can we talk a little about in this hood itself? What is some of this material made out of? Can you talk to us a little bit more what's gone into that?
So this hood right here is used with 3/8 aluminum that we cut up on a CNC router. And that, in addition with the shoulder bolts, helps it to, if you want to go up.
So it's just like a powder-coated aluminum that's on it?
Yep, that's just powder-coated aluminum, and then those shafts are as well powder-coated aluminum.
So there's a lot of compression and the power cells rubbing against that. Do you have to like reapply the powder coating, or does it lose grip or anything like that over time?
So actually, we have not had to deal with any of that.
Sure.
Typically, if that was an issue, we would figure it out using different types of wheels inside of the column instead of changing the material type. Our original shooter in 2020, we did have to do certain things with a backboard, using different things like Lexan and like a felt. But with this one, there has been almost 0 modifications to this specific area.
Sure.
And it has been consistent.
Let's start the wrap up on your robot and talk about your climber a little bit. What's gone into that? Looks like a couple different arms on each side with some tension springs. Talk to us about what's gone into that design process.
So originally in 2020, we had a winching system that allowed us to go up, and it was very secure, and it held us up. And the problem with that is if we went up and needed to go back down, that wasn't something we could effectively do.
Can we see the climber deploy up? And we'll kind of see this process here.
So with our new climbers, that has allowed us to bring it up and then bring it back down if we need to readjust at any point. And it's also a lot more stable.
Can you talk to me about this giant piece right here, kind of how this plays into it?
So during quarantine, when we couldn't really meet as a team, we wanted to still do team activities. So that was for us biking. And so that's kind of a big part of our team. And so we wanted to kind of show that on our 2021 robot using this big bike braking bike caliper. And
Sure.
that works very well to hold a robot in place as a brake using this pneumatic piston over here. And it also just kind of shows a little bit of our spirit as a team.
Perfect. Anything as we wrap up from a programming side, from a climber you want to talk about, or automation-wise?
Yeah, so with the climber, we had a lot of issues because we had to redesign it multiple times.
Sure.
And one of that issues is that since we use a winching system, it was difficult to know how far you had to winch. So at one point, we had Sharpied how far we were supposed to winch on the top, if you can see that there, because we tried pretty much everything. And then eventually...
It's only weird if it doesn't work, so.
Yeah, and it worked for a while, but it wasn't good enough for us. So we put in some limit switches, which wasn't difficult to program. It was quite easy. And it makes it a lot easier. That way, when you winch down, it stops. It's nothing that the operator has to do. You press the button until it stops, and then you're up. And then we have the autonomous function of it flipping up and going all the way out, because just it helps save time.
Yeah.
That way we can climb as fast as possible, because we have had issues with them not going up at the same time, so it makes it a lot easier to just do that autonomously.
Well, 5460 Strike Zone, once again, thanks for taking the time to tell us about your robot, what's going on here. As we're filming this, they've had a couple great matches so far, and looking for, of course, more here at Chesney Champs. So can't wait to see this robot perform here, and of course, seeing your team in future in First in Michigan. Good luck.
Thanks to Kettering University for their support of this video. Don't just sit in class. Kettering University is the only school in the U.S. that allows you to work as an engineer your first year with their 3-month on, 3-month off co-op programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. We'd like to thank Stryker for their continued support of First Updates Now. Stryker's internship portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.